Today we are focused on upthrust or buoyant force. I want to start with one example. Let's say this is a vessel, it contains water, and if a body is weight in air and its weight is, let's say, 5 Newton, and if you take its weight inside the water, then do you think that it remains 5 Newton again? No, it will reduce. Let's say it is reduced to 4 Newton. Then what is the reason of reduction of weight in water? Certainly, water exerts a vertically upward force on the body, which is called upthrust. We can take another example also to experience the upthrust. Let's say we have a vessel which is partially filled with water, and if a wooden block is taken, it is taken into the water, holding it with our hand, then what happens when you release your hand? The wooden block comes up to the surface of the water and it floats. This vertically upward force acting on the wooden block is called upthrust, which is also called buoyant force. A resultant force acting vertically upward on a body when placed in a liquid is called upthrust or buoyant force. Now I want to tell you the reason of upthrust. Let's say we have a vessel and a body having its edge A, B, C, D is immersed into it. Now certainly water exerts pressure from all the sides, from the side AD also and BC also. But the pressure on AD and BC are equal because the surface AD and BC are at the same depth. That's why the pressure on AD and BC are equal, because pressure increases with the depth, but both the surfaces are at same depth, so pressure is equal. We know that pressure equal to force by area. Pressure is if equal on both of these surfaces, area of AD and BC is also equal. If pressure and area both are equal, then force is also equal. It means force acting on AD is equal to the force acting on BC by water. And since these two forces are acting in opposite direction, that's why they cancel each other. Resultant force becomes 0. But the pressure acting on the surface AB and pressure acting on the surface CD, do you think they are equal? No, because the surface AB lies at less depth, but the surface CD lies at greater depth. And we know that pressure increases with the increase of depth. That's why pressure on CD is greater than pressure on AB. If pressure on CD is greater and both of them have same area, then certainly force acting on the surface CD is greater than the force acting on the surface AB. So, as a result of all these forces, a resultant force acts on the body in the vertically upward direction. This is upthrust, and this is the region of upthrust or buoyant force. Okay, now we know what is upthrust and how it produces on a body. Okay, this much for today. Thank you.